Hey, if you're working with an application that exposes APIs for login, payments, data fetching, and more, you might have already thought about rate limiting it. Or if you haven't, you should. So that you can make sure that no one can flood your servers with thousands of requests at once. This sounds simple, but when you actually get into the details of it, you would realize how much tricky this actually is. Because the catch is, most of these rate limiters work using IP addresses as the base. This is perfectly fine until you realize that multiple users can share the same IP addresses, like people working in cafe, people working in offices, and more. And a single user can also have multiple IP addresses as well. So suddenly you're blocking the real users and letting an attacker slip through. So instead of limiting by IP addresses, we need a far more fair approach, which would be limiting by user identity instead. And this is exactly what we're going to learn in this video. Okay, so let's start with the question, why? Why do we even need this? See, the first thing is, let's assume that we have a login and an orders endpoint. Okay, so without rate limiting, an attacker can send through thousands of requests per second trying to guess a password of the user, which is a both security risk as well as a load on the server. And similarly, a simple bug or let's say a malicious script can send thousands of order requests for this order endpoint, which can disrupt the entire inventory management and also put a load on the server. So rate limiting here acts as a speed governor, defending against these malicious attacks or an accidental requests coming through, and helps your server to be stable, fair, and available at any time, no matter what comes in its way. All right, now let's move on to understand what are the common ways to actually create this rate limiting. We call this as rate limiting algorithms. All right, now let's talk about implementing rate limiting. So there are 4 algorithms commonly used while implementing rate limiting. So let's talk about that. The first one is fixed window counter. So very simple. So you would define a time frame, let's say 1 minute, and you define a number of requests, let's say 100. So 100 requests per minute. And you would track these values. So if the request is below 100 and within the minute, then you would allow it. Or else if it goes beyond the 100 within the same minute, you would reject it. But the only problem here is, let's say the timer is 0059 seconds. Okay, so 1 second is left for this minute to end. So if the current request is 99, which is below the limit, the next second resets the entire time, right? This is we call as the boundary. It resets the entire time. So now the user can get another 100 requests. So within a second, they got 199 requests, and we call this as burst. Okay, so that's the only problem with fixed window counter. Coming to the sliding window counter, a bit improved version of fixed window counter. So instead of calculating based on the current minute, you would calculate based on the previous n seconds. So let's say 60 seconds. So you would think, okay, the limit is 100, and in the past 60 seconds you have made so and so request, and you can only get certain amount of requests at this particular moment of time. So based on that, you would either reject it or serve the request. This is a bit improved version of fixed window counter, and it provides very good accuracy rate in terms of rate limiting, but it is a bit complex to implement. So you might have to think about it before you implement this solution. Coming to the next one, we have leaky bucket. So leaky bucket is kind of simple. So you have a bucket, you fill that with the requests coming in, and you have only one hole at the bottom of the bucket. So the requests that are being filled in the bucket flows one after the other in a steady rate. Okay, so the server can easily predict the amount of traffic it's getting and can easily serve them without being overrun. The only problem with this is the bucket can get full because of a lot of requests coming in, and maybe the new requests that are coming in after the bucket is full might be dropped, which can affect the new users as well. So might have to think through before you actually implement this. All right, coming to token bucket, it's a bit simple and different from the other algorithms we have. So every user will have a token assigned to them, which they can use to make the request. And whenever they make a request, one token is consumed. And this consumed token is regenerated based on the given time. So if you can allot 1 second or 1 minute for this token to regenerate, and within that time frame, it keep on regenerating. And only after that time, it will be ready to be used again. So this makes sure that the user cannot make requests beyond their given quota, and also helps the system to be safe. Okay, this also allows burst if they have the token, but also make sure that it maintains long-term stability. And this is the reason why token bucket is widely used, because it's very simple to implement and it's very flexible. You can play around with the time, and it's very scalable across any distributed systems you're building. Okay, and in this video, we'll actually be using token bucket. Okay, we'll be assigning tokens for the user, and we'll actually let them use this token whenever they're making the request. All right, sounds good, right? Let's go. Okay, so talking about our implementation plan, So we will be building this rate limiting system that uses token bucket. And let's say we have different tiers. So for example, here we have Alice on free tier, Bob on silver tier, gold, platinum, so on and so forth. So each of these tiers will have their own set of tokens assigned to them. And it takes 1 minute for the entire token to regenerate. For example, free tier has 2 tokens and the silver tier should have like 3 or 4 tokens. And no matter how many tokens they have, it all takes 1 minute to reset. Okay. So this makes sure that we're not using IP addresses to rate limit these users, and we don't block users just because they're using the same Wi-Fi from cafes or company or something like that. And there is no loopholes for this if people switch IP addresses, or maybe they're using VPN or something like that. Okay, so if you have token, you can make a request. Each token consumes 1 request. Okay, so let's see a demo before we actually get our hands on the code. So I'm selecting Alice as a free user over here, and then I'm going to send hello as a message. So I'm going to click on send, and this will just say simulated AI reply called hello, and then I'm going to send again. Okay, so now 2 requests has been made, and when I try to send the 3rd request, it says rate limit exceeded, retry after 21 seconds. So basically what happened was, when I sent the first message, the first token was used, and it was sent 9 seconds before I sent this particular request. So since we have 1 minute timeline here over here, and we have 2 tokens for the free tiers, it takes 30 seconds for 1 token to regenerate. And if I try again, you can see it worked. And if I try again, oh, I have to type a message. You can see it says 20. So now 1 token was regenerated, which we were able to use here, but there was no other token left out for Alice, unfortunately. So this is what token bucket is. So you can send the request as long as you have the token, but when you run out of the token, you have to wait until it regenerates. Okay, so this is the simple demo that we'll be building. Very simple to implement and very, very effective. Even you can actually implement this in your production code. It actually works like I don't know, it works out of the box. Okay, so let's start with the code. All right, now talking about the code implementation, we have a very simple Express application. Okay, you can use this with anything you want, literally any language, any framework, whatever you're using, it works. Just understand the concept, that's all. Okay, so here I have an Express API already set up. Okay, it's very simple Express app, and I've defined the list of users I want. You can also plug this with your DB where you have the users, and a couple of utility APIs like get all the users, check the status if the Redis is connected, and also toggle rate limiting. So basically we had this toggle in the UI, we were experimenting something, so this was the API. So no significance or whatsoever for this actual thing we are learning. Okay, so you can ignore this. And we have ts.ts over here that defines what is the limit. So for free tier we have 2, for silver it's 5, 10, 15, so on and so forth. Okay, so for 1 minute you can make 2 requests as a free tier, 5 requests as a silver, 10 as gold, something like that. Okay, and then we have Redis client.ts over here, which is connecting to Redis, nothing much. You can use anything you want. You can use your own memory, basically store everything in a memory instead of Redis, or maybe in the database instead of Redis. It's up to you. So we are using Redis to track the amount of tokens available for the user and how many of these tokens have been used, something like that. Okay, very simple, just connection over here. Okay, straightforward. Cool. Now coming back to server.ts file. So let's start with defining the API first. So we'll start defining chat. Okay, that chat is our endpoint we've used in the UI in the demo, and we'll actually get the user ID and the message they're trying to send for us. Okay, ignore the autocomplete. They're not useful for us at the moment. Okay, and then we would actually find the user. So basically we're using this array over here to get the user. Okay, and if we don't find the user, we're gonna just say 404 user not found. Straightforward security check. Okay, and then we're going to get the limit of the tier. So basically if we found the user, let's say we are requesting as an Alice tier is free. So we're going to get that tier, and then we're going to get the limit. So we're going to get the limit from this one. Okay, tiers. So free tier is 2. So now this limit constant will be 2. Okay, then we're going to add if rate limiting is not enabled. Basically we're checking if the rate limiting is enabled or not. Okay, so this is something like we did before. You can also implement this if you want to disable rate limiting, okay, for let's say debugging purpose or something like that. So we're going to set some headers, and then we're going to time out with the response. So what I am doing here is whatever message you send, we're just delaying it by 1 second and giving you simulated AI response with the same message. So if you send hello Pawan, I'm going to give you back hello Pawan, just prefixing that with simulated AI reply. That's all. Okay, and then we're going to delay it for 1 minute just to simulate some processing power inside it. Okay. And moving on, so if it's rate limiting is disabled, we're going to just return the response without any rate limiting check. Okay, you can use this for debugging purposes, or maybe let's say whitelist some users who can bypass rate limiting. Okay, so if rate limiting is enabled, the first thing is we do is we add try catch block because it's an async function. Okay, and the next thing is we're gonna add some console logging or handle the error first so that we don't forget it at the end, because we tend to do that. And the next thing is we'll define a couple of constant. The first thing is key. So this key will be used to track your rate limiting throughout your request cycle. Okay, so it's basically rate colon your user ID, so it's unique only to you. And the next thing is we get the date. So what is the current timestamp at the moment when the request is being made, and we calculate the refill rate. So refill rate is limit divided by 60. So per 60 seconds, meaning 60 is 1 minute, you can increase it if you want. So what is the amount, or let's say fraction of the token we generate, something like that. Okay, so our goal is per minute we generate some kind of let's say per minute we generate 2 tokens for Alice, right? So coming to that, every second, so 1 minute is 60 seconds, right? So for every second, what is the fraction of the token we have to give? So it's not like after 1 minute you get the entire token. It's like per second the token keep on filling up, and at the end of 1 minute it is ready for you, something like that. Okay, so we calculate the refill rate over here, how many token do you have to refill. Okay, and then we get the data, that is the client Redis. We go to Redis, ask for the user's key, we see if there's any data or not. Okay, and then we just get tokens and last refill variable here. So if the data doesn't exist, let's say it's the first request from the user, there is no request being made before, then what we will do is we will add the limit to the tokens. So basically this limit, that is number 2. Okay, from here, where is it? From here we would add that. Okay, and the refill rate is now. So we'd say that, hey, the 2 tokens is allotted for this user, and the last refill was done at the moment. Now we're just going to add it as a placeholder. So we just refilled it now, and the limit of this user is 2 tokens. Okay, and then we add else statement if the data exists. Okay, so we're going to get the data from Redis, we're going to pass it, and then we're going to calculate the amount of tokens available of that user, and then we're going to get the last refilled data as well, and then we can assign that to tokens and last refill. Okay, and then we calculate the amount of time elapsed from the previous last refill. Okay, and then we calculate the refill amount that's supposed to be done, and then we calculate the tokens. Okay, basically math minimum. So we're going to calculate what is the limit and the amount of tokens that is to be refilled. So this makes sure that this doesn't go beyond the limit that is assigned. So if it's freemium, it's 2. So this math.minimum will make sure that for Alice it doesn't go beyond 2 for the tokens. Okay, now we're going to assign the last refill is 2. So basically what we're doing here is we are calculating. Okay, so now the request is being made. We're going to go back, check the amount of time that was refilled last time. So we're going to calculate again if it's supposed to be, if we want to give the new token for the user, or is there still time left for the new token to generate? That's what we're doing here. Okay, and let me remove that. All right, now we have token is greater than 1. So if it is greater than or equal to 1, basically checking if the request has tokens or not. If the token is there, we're going to decrement it, basically minus 1 from the tokens, and then we're going to update that to Redis again, and then we're going to set the header for the user, some rate limiting headers, then we're going to send the request. Okay, if not, let's say token is not available, then we're going to set the same thing to Redis again. Okay, then we're going to say retry after, basically saying that you don't have tokens, so you can retry after. We can calculate the amount of seconds left for the next token to regenerate, attach that to the headers. We're going to say, let me close this as well. So rate limiting, so time remaining is 0, retry after seconds, and then we're going to send the request saying rate limit exceeded, the limit of the user remaining is 0 token is remaining, and retry after, let's say 21 seconds, 10 seconds or something like that, and then return. That's all. Okay, very simple, straightforward. Let's recap again. So the first thing is you would get a unique key of the user using their user ID. Okay, and then you would get today's date and then the refill amount. Okay, what refill rate, basically how much token do we have to refill for every minute. Okay, now coming back again, you would see if the user already has the data in the Redis. Basically, is this a new user or is this an existing user? Okay, if it's the new user, we're gonna set the token of the user limit. So basically if it's Alice, it's 2, and then we're gonna get the last refill, that is now. So we're gonna tell Redis that, hey, this user has 2 tokens and the last refill done was at the moment, it's now. If not, if the data already exists, meaning it's a recurring user, then we would get the data from Redis, parse it, okay, reset the same tokens and last refill to these variables so we can use it internally. Okay, and then we will calculate the elapsed time, basically comparing with the last refill time, how many seconds has been passed, okay, at the moment. So if it's more than 60 seconds, let's say for 1 minute, we're going to reset all the tokens, right? So if it's more than 60 seconds, we're going to give them back all the tokens because it's been 60 seconds already. So they're eligible for all the tokens. So that's what we're doing. So if it's more than 60 seconds, okay, we'll calculate the refill amount and then we will attach this. So this refill amount plus tokens can be 10, 20, 50 also. But since we're using math.minimum, okay, we're attaching, hey, this is the limit let's say the user is coming after 10 days. So within 10 days, the user might have earned, let's say, 1,000 tokens, but the limit is 10 or 5 or 2. So this math.min will make sure that it only give that limit for the user. Okay. So now we'll update the token and the last refill. Okay. The latest one. Okay. And then we will check if the token, basically this one. Now we will check if the token is there or not for the user. If it is there, we will -1, update the latest data in Redis, okay, and then set the header saying that your limit is so and so, and the time remaining for the next token to regenerate is so and so, and here's the response you went through. Okay, if the token is not available even after calculating elapsed time and everything, then we will update the latest data in the Redis, okay, basically latest time, whatever we were calculating. Let's say the user had 20 seconds to regenerate the token. They sent another request again. Now it's 19 seconds. So we're updating that 19 seconds over here, okay? And then we're going to calculate retry after. We're going to say you have to retry after 19 seconds and then set the headers and then send the response. And the setting header is actually very important because this is the standard. Okay, you have to send these headers. This is a very standard, and these headers has to have the exact same key. This is the standard. Okay, not something I'm cooking up here. Okay, all right. So this was very simple, right? Very simple approach to implement, and we did implement this within few lines of code. Okay, very simple approach. You can implement this at any scale you want. It works flawlessly. So this was about the code implementation, and this will work flawlessly. And you can actually extract this as a separate middleware and plug it into any number of APIs you want. I just added it here since I had only one API. Okay, now let's talk about use cases. Where can you actually use this type of implementation? When you talk about rate limiting use cases, you can use it anywhere you want. Literally 99% of the applications you're building, you can use rate limiting over there. But the only question comes in is, do you even need it? Do you have a large user base? And are you getting a lot of requests or let's say traffic spikes for your server? If no, then don't use it. If yes, then use it regardless of what you're building. If you're building a very public facing applications like social media applications, then you must need it. If you're building applications like ChatGPT and the stuff, you definitely need it. Okay, or if you're building completely public APIs, okay, like payments and other SaaS products which is exposing SDKs and APIs, then you definitely need it. Okay, so take a moment and think about the amount of users making a request and the amount of time it requires for your server to serve that request, and then decide if you need rate limiting here or not. Okay, just to recap, rate limiting is not a complete 100% solution as a security for your application. You need to think about other security protocols as well. But rate limiting is one of the details that you can use to defend against abuse and malicious use of your server. Okay, with that said, thank you so much for watching, guys. Please do follow us in all our social media platforms. We will be coming up with a lot of micro content like this, which will make you a better developer and build resilient systems. With that said, thank you so much. Until next time.